Hello guys, welcome back to the channel. So today we'll be doing linear approximation or linearization of a function at a point. So let's suppose we have a function f that's differentiable at a point x is equal to a. Then the linear approximation of f is giving us y is equal to f of a plus f prime at a multiplying x minus a. So here f of a is the function value at a and f prime of a is the function value at the first derivative of f evaluated at a. So here all that we need to find is our a, f of a, and f prime of a. So let's try our first example on linear approximation or linearization of a function. So with example 1, we have to find the linear approximation or the linearization of f, giving us the square root of x at the point x is equal to 9. So here our a is giving us 9. Now, by the linearization formula, we are going to use y is equal to f of a plus f prime at a x minus a. So here let's find f prime. So here let's differentiate f with respect to x. So we're going to have f prime of x is giving us, now we have to differentiate square root, right? So we can rewrite the function f to be x exponent 1/2. So now let's differentiate and see what we are going to get. So we are going to use the power rule to differentiate. So 1/2 x, then we decrease the power by 1, that's minus 1/2. So our answer is 2 on the square root of x. So this is f prime of x. Now by the linearization formula, we have to evaluate this at a. So we have to evaluate f prime at a. Here a is 9, so we are going to have 1 on 2, then square root of 9. So that will be 1 on 2 multiplying 3, that's 1 on 6. So now we have f prime of a. Now let's find f of a. That's the function value at a. So we have our f of x giving us the square root of x. Then what will be f of 9? So f of 9 will be the square root of 9. That's 3. So we have all that we need. So our linearization will be giving us y is equal to f of a plus f prime of a x minus a. So we are going to have, what's f of a? That's 3. 3 plus what's f prime at a? That's 1/6. Then x minus what's a? A is 9. So we are going to have 3 plus x on 6 minus 9 on 6. So now let's simplify further. 3 plus x on 6 minus 3 on 2. So that's our linearization of f of x is equal to square root of x. Alright, so here we have to use it to approximate the square root of 9.1. So we are going to have the linearization of 9.1 is given us. So here, wherever we see x, we are going to put in 9.1. So we are going to have 3 on 2 plus 9.1 on 6. And this will give 3.01667. So this is the linearization at the point 9.1. So now let's try our second example. So we have to find the linearization L of x of a function f of x is equal to ex at a is equal to 0. So we have L of x is giving us f of a plus f prime at a x minus a. So we have a at 0. So we are going to have f of 0 plus f prime at 0, then x. So now let's find f of 0. So we are going to have f of 0 to be e of 0, that's 1. Now let's differentiate f. So f prime of x will be giving us, when you differentiate ex, you still have the same function ex. So here's going to be ex. Then evaluate f prime at 0. So we're going to have that one to be 1. So we have this guy as 1, and this is also 1. So our linearization L of x will be giving us 1 plus 1 multiplying x. That's 1 plus x. So this is our linearization. So let's compare our answer to the options given above. So that's option D. So now with our next question, we've been given the linearization of g as 1 plus 1/2 x, and we are to use it to estimate the value of this cube roots of 1.1. So here, what's g? G was giving us the cube roots of 1 plus x. So now we have to use it to evaluate this guy. So now here, observe that we can write the cube roots of 1.1 as the cube roots of 1 plus 0.1. So in this case, what's your x? Comparing this with the g function, your x is given as 0.1, because here is 1 plus x and here is 1 plus 0.1, so your x is 0.1. So we just have to substitute in our x into the given expression. So now our linearization will be L of x giving us 1 plus 1/2 x. This is given the question already, so our x is now 0.1. So L of 0.1 is equal to 1 plus 1/2 0.1, and this will give us 1.05. So our answer is option D. Alright, so now let's take our last example on linearization. So here we have a function f of x giving us x minus 1 all squared, and g of x giving us x minus 2x, and we have to find the linearization of both f and g at a is equal to 0. So here I'll do the first one, that's f of x, then you guys should try that of g of x. So now let's find f of a. That's the function value at a. So here a is 0, so you're going to find f of 0. Now what to be f of 0? That's 0 minus 1 squared, that's minus 1 squared, and that's 1. So now let's find f prime of x. We are going to use the chain rule to differentiate this. So we are going to have 2x minus 1 multiplying 1, so that will be 2x minus 1. Now we find the function value at 0 because a is 0, so you're going to have 0 minus 1, and that's minus 2. So now we have all that we need, so let's just substitute it into the linearization formula. So L of x is equal to f of a plus f prime at a x minus a. Here a is 0, so you're going to have f of 0 plus f prime of 0 multiplying x, and we know f of 0 to be 1 and f prime of 0 to be minus 2, so you're going to have it to be 1 minus 2x. So this is your linearization of f of x. So now let me do the g of x quickly. So here we have g of x giving us e minus 2x and a is equal to 0. So we need g of 0. Now, so g of a, that's g of 0, will be giving us e minus 2 of 0, and that's e of 0, and that's 1. So by the formula, we need g prime at a. So now let's differentiate. Now differentiating g of x, this is an exponential function, so now you're going to differentiate the exponents, then you multiply. So when you differentiate minus 2x, you're going to have minus 2, so you multiply it with the original function, that's e minus 2x. Now let's find g prime at a. So here a is 0, so g of 0, that'll be minus 2 of 0, and that'll be minus 2 e of 0, and that's minus 2. So now we have everything that we need. So L of x, that's our linearization formula, is giving us, so here is g of a plus g prime of a x minus a. So that will be g of 0 plus g prime of 0 x. Now what's g of 0? That's 1 minus 2 because g prime of 0 is minus 2 multiplying x. So our linearization is giving us 1 minus 2x. Now all that we notice from these two is that the answers are the same, because we have that of y to be 1 minus 2x, and now that of g is giving us 1 minus 2x. So our answers are the same. Alright, so that's it for today. See you in the next video. Bye bye.